All right, so this is video 7 for the behavioral analysis series. I figured I'll do another example of involving supremum slash infimum. This one's going to just be a supremum example. Well, let's say you're given two sets, A and B, of the real numbers that are bounded above. Define A plus B to be the set, so capital A plus capital B to be the set of lowercase a plus lowercase b, such that A is in A and B is in B. We're going to prove that the supremum of this set is equal to the supremum of A plus the supremum of B. All right, so before I go into the proof, now these are just visuals to sort of discuss. So we have our set A on the real number line. I just wrote in green, supremum, that open dot. Now the supremum does not have to be part of the set, so that's why I put it as an open dot. And then same thing for B in pink, and then here in orange is A plus B, and then its corresponding supremum. Now, as far as just a simple example, let's say you had the open intervals 2 to 3 for A, and then 4 to 5 for B. The supremum of A is 3, and the supremum of B is 5. Now the set A plus B is going to be 6, 8. You add the elements from each set, so like the sort of like the lower bound of 2 plus 4 is that's going to be 6, and the upper bound, that's 3 plus 5, that's 8. So the supremum of the open interval 6 to 8 is 8, and if you add each supremum of the individual sets of A and B, so you get 3 plus 5 is also 8. Now this isn't a proof, that's just a simple example. Now for the proof itself, I wrote down a strategy. And for the strategy of how we're going to approach this is that to show equality of A equals B, you can show that if you have A is less than or equal to B, but yet B is less than or equal to A, then it has to be that A equals B. So to show that the supremum of A plus B equals the supremum of A plus the supremum of B, we'll show the inequality of both sides of as far as doing the supremum of A plus B being less than or equal to the supremum of A plus the supremum of B, and then the other way, supremum of A plus supremum of B being less than or equal to supremum of A plus B. So since they're both less than or equal to each other, then you have to have it to be equality. And here's just the definition of supremum. U equals the supremum of some set S. Well, first U is an upper bound of that set. So S is less than or equal to U for all S and S. If W is any upper bound, so emphasize the word any, if W is any upper bound of S, then you'll have U is less than or equal to W. Okay, so the proof. All right, so given two sets A and B that are bounded above, well, since they're bounded above, we know the supremums exist. So sup of A exists, sup of B exists, since they're each set's bounded above in the real numbers. So we're going to define the set capital A plus capital B, be the set of lowercase a plus lowercase b, such that lowercase a comes from this capital A and lowercase b comes from capital B. All right, so we wish to show the supremum of this set that we just defined is equal to the sum of the supremum of the individual sets. So sup of A plus sup of B. And we'll break it up into two cases. So case I, or case 1, will show less than or equal to. So supremum of A plus B is less than or equal to the supremum of A plus the supremum of B. All right, and then after that, we're going to show supremum of A plus supremum of B is less than or equal to supremum of A plus B. All right, so we're going to pick an arbitrary element from A plus B, capital A plus capital B. So pick any element, and it's going to have the structure lowercase a plus lowercase b in our set, capital A plus capital B. Well, we know by definition of supremum, we know A is less than or equal to the supremum of A. And then B is less than or equal to the supremum of B. So then A plus B would be less than or equal to the supremum of A plus the supremum of B. So what does this say? So we have A plus B is an arbitrary element of our set, capital A plus capital B. And we've produced some value where it's sup of A plus supposed to be sup of B is greater than or equal to that particular arbitrary element. But this implies that this is an upper bound. So this means sup of A plus sup of B is an upper bound for our set. Well, we know the supremum of our set is the least upper bound, but supremum of A plus B is the least upper bound. All right, so in our definition, so if W is any upper bound of some set S, then the supremum U is less than or equal to any upper bound W. So in this case, we're letting our supremum of A plus B is going to be less than or equal to any upper bound of A plus B. And our W, since it's for any upper bound, and we said that sup of A plus sup of B is an upper bound, then it must be that that the sup of capital A plus B is since it's the least upper bound, then sup of capital A plus B is less than or equal to sup of capital A plus sup of capital B. Since our elements A plus B is arbitrary. All right, so that shows the first part. That's the easy part, is case 1. Now case 2, we're going to show that the supremum of A plus the supremum of B is less than or equal to the supremum of A plus B. All right, so this is I think this is the more difficult case. All right, so we're going to let A be an arbitrary element. So let A and capital A be arbitrary element. I cannot spell today, sorry. So again, for any or arbitrary B, so for B and capital B, then we have A plus B, which is an element of our set capital A plus capital B. And we know that that's got to be less than or equal to the supremum of capital A plus B. So A plus B is less than or equal to the sup of A plus B. Since that's our supremum is, and then we can rearrange this. So this would imply that A is less than or equal to the sup of capital A plus B minus this arbitrary element B. Okay, and this is since this is supremum. All right, so we have, and we rearranged it just by subtracting B. And so we have A is less than or equal to sup of capital A plus B, and then minus this arbitrary element B. But what does this say? So A comes from capital A, it's arbitrary. And then we have this supremum of A plus B, so this thing is a number. So this is a value that's fixed. So that's going to be itself an upper bound for A. So sup of capital A plus B is some fixed arbitrary number that follows, that suits as a, that is an upper bound that serves as an upper bound for capital A, because we know, but we know what the least upper bound is. So sup of capital A is the least upper bound. All right. So therefore, for our arbitrary element A is less than or equal to the sup of A, but that's less than or equal to the sup of A plus B minus B. Right, because of our definition of supremum is that in this case, if W is any upper bound of some set S, then the supremum is less than or equal to that the arbitrary upper bound. And in this case, we know sup of A is the supremum. It's the least upper bound for our set A. So then that's got to be less than or equal to this other upper bound, or this sup of A plus B minus B, which it potentially could be sup of A. So that's why we got to keep the less than or equal to. All right, so what can we derive from here? Well, let's see. We can try to rearrange this inequality and do some similar reasoning for B. All right, so we're gonna try to rearrange this. So just to clean it up, I'll just go ahead and just write it as sup of A less than or equal to sup of A plus B minus B. And if I try to rearrange this, I could add B to both sides. So I'd have B plus sup of capital A less than or equal to sup of A plus capital A plus B. Subtracting sup of A from both sides, then that means I have B is less than or equal to the sup of A plus B minus the sup of A. All right, so B is arbitrary, so we know this value, so sup of A plus B minus sup of A serves as is a fixed arbitrary value that serves as a upper bound for the set B. So sup of A plus B minus sup of A serves as an upper bound for B. And we know B is arbitrary. And we know the supremum, the least upper bound of B. So then this is an upper bound. Sup of A plus B minus sup of A is an upper bound. B is arbitrary. So the least upper bound for B is such that we have B less than or equal to the sup of B. Since it's the least upper bound, then less than or equal to this other upper bound. All right, and again, that's because B, sup of B is the least upper bound for B. And so then what can we get? So we can add sup of A. So we'll clean it up a little bit. I'll just go ahead and write it as just sup of B less than or equal to sup of A plus B. Minus sup of A. If we add sup of A to both sides, that's going to give us sup of A plus sup of B is less than or equal to the sup of A plus B. All right, and that again, A was arbitrary, B is arbitrary, so our A plus B element is also arbitrary. So that ends case 2. So we've shown from case 1, sup of A plus B less than or equal to the sum of the sups from each one, sup of A plus sup of B. That was case 1. And then we just did the second case. So therefore they got to be equal. All right, so make sure that's completes the proof. So the second case I would say was a little bit more tricky. So we had to show sup of A plus sup of B less than or equal to sup of A plus B. You pick arbitrary elements A and B and B. Then you have A plus B is an element of capital A plus capital B from that set. And we know that since it's arbitrary, then that arbitrary element A plus B is less than or equal to the supremum of the set. And then you could subtract B so that you have A is less than or equal to sup of A plus B minus B, which would imply that that value sup of A plus B minus B is a fixed arbitrary value that serves as an upper bound for A. But we know supremum sup of A is the least upper bound, so therefore we get A is less than or equal to sup of A, which is less than or equal to the upper bound sup of A plus B minus B because of the definition of supremum. As far as if W is any upper bound of S, then the supremum U is less than or equal to W. And we do a similar thought process for B. Right, we just rearrange this inequality so that we get B is less than or equal to sup of A plus B minus sup of A. So that arbitrary fixed value of sup of A plus B minus sup of A is an upper bound for B. So the supremum of B is such that you have B less than or equal to supremum of B less than or equal to supremum of A plus B minus the supremum of A, which then you could just from there add sup of A, and then you get sup of A plus sup of B less than or equal to sup of A plus B. All right, so then that was the second case. So we showed both inequalities. Since they're both less than or equal to each other, then it has to be that they're equal. So that is it for this video. The next video, I'm going to start on a sort of different thing. Instead of examples, I'll go over some more concepts.